This is my Precalculus course. Today we're going to do some trigonometry review. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, in the first class of this course, you may recall that I mentioned that there's two versions of Precalculus. One version that includes an entire trigonometry course within it, and one version that does not. The version that I'm teaching here is a version that does not include an entire trigonometry course within it. But we do still need to review some trigonometry. Now, if we reviewed all of the trigonometry that was covered in my prerequisite course, then it would take about 8 classes to do that, and you'd have to cover all this information here. But we don't need to cover all the information. So we're just going to do one class as opposed to 8 classes. So again, we are doing some trigonometry review, but we're not going to review the entire course. Now be aware, as I said, that my trigonometry course is a prerequisite for this Precalculus course. Or you need to take a trigonometry course from somewhere else. Whether it's my course or somewhere else, you need a full trigonometry course before taking this course. So this is going to be a review, but if you haven't fulfilled that prerequisite, then you're going to be pretty confused. So we learned a relationship between the sides of right triangles, the Pythagorean theorem, and we learned a relationship between the angles in any triangle. That was the triangle sum theorem. So we have a relationship that is side-side and a relationship that is angle-angle. But trigonometry is the relationships between the sides and the angles. So side-angle. Now, you know these 6 basic trigonometric functions, but if you forgot them or you're worried that you may need them in front of you, you can take a picture of this information. And I know that this is probably easy for a lot of you who have taken my trigonometry course, but we do need to refresh our minds on these basic definitions. So let's try some practice problems. So sine is defined to be the opposite side length over the hypotenuse length. And it says A, so in this case the angle is named after the corner of the triangle, or the vertex. So we have to look at the side opposite angle A, which is 15, and divide by the hypotenuse, which is always the side opposite the right angle. It's also the longest side. This hypotenuse is always the longest side. Divide both sides by 3, and we get 5/13. So that is sine A. In this example, we're naming the angle with an expression that notates the actual measure of the angle. So that's another way to write the angle. So cosine theta is the side adjacent to theta, which is 36. 39 is also adjacent, but 39 is the hypotenuse, so we don't call that the adjacent side, even though it is adjacent. So adjacent theta divided by the hypotenuse, and if we divide both sides by 3, we get 12/13. And now we're naming the angle with the vertex again, and now we're at a different vertex. So tangent B is defined to be the side opposite that angle. The side opposite the angle divided by the side adjacent to the angle. And again, the hypotenuse is adjacent, but it's not called the adjacent side. So that reduces, divide both sides by 3, and you get 12/5. All right, now we're going to find cosecant omega. So again, we're now naming the angle with the actual angle measure. Cosecant is the hypotenuse divided by the side opposite the angle omega, so that's 36. Divide both sides by 3 to reduce, and we get 13/12. So secant A, we're looking at this angle up here, is the hypotenuse over the adjacent side of A. And cotangent theta is defined to be the side adjacent theta, which is 36, divided by the side opposite theta, which is 15. Divide both sides by 3, and we get 12/5. So, again, we can name angles by the vertices of the triangle, or we can name the angles with an expression that represents the actual measure of the angle. So let's try another one of these real quick. So if you've got these definitions in front of you, then this should be pretty easy. So get a picture of that again. And some of you may remember this without having to look at those definitions. So sine alpha is a side opposite divided by the hypotenuse. The side opposite the alpha angle. And we can reduce cosine B. We're looking at this angle down here. Cosine B is the side adjacent B, which is 2 over the hypotenuse. So that ratio is 1/3. Tangent beta, we're looking at this angle now, is side opposite over adjacent. And we can reduce that expression, so we get 1/2√2 if we divide both sides by 2. But then we do need to rationalize the denominator. Remember, you can't have a square root in the denominator. So we're going to multiply both sides by √2. And we get √2 over 2√4. And √4 is just 2. So I want to make it clear that became the 2 there. And then we have √2/4 is our final answer. Now we're going to find cosecant A, which is the hypotenuse divided by the opposite side. So that reduces to 3. And then secant alpha is the hypotenuse divided by the side adjacent alpha, which is 2. So that's also equal to 3. And then we have cotangent beta, so that's the side adjacent beta divided by the opposite side. So that'll be 4√2/2, which is 2√2. And there you go. Let's try one more of these. Now in this example, we're actually given the angle measures. And the side lengths we don't actually know. So let's find sine 39 degrees. That's the side opposite 39 divided by the hypotenuse, so that's y/r. Cosine 39 is the side adjacent 39 divided by the hypotenuse. Tangent A is the side opposite A divided by the side adjacent. And cosecant 51 degrees is the side, well, it's the hypotenuse divided by the side opposite 51 degrees, which is x. And secant B is the hypotenuse divided by the side adjacent B, which is y. And cotangent 51, that will be the side adjacent 51 degrees divided by the side opposite. So there you go. So I know that that's probably a little easy for students who are coming out of my trigonometry course, but nonetheless we need to review these basic concepts. So try number 4, and when you come back we'll do it together. Okay, we're back. So those are the answers for number 4. If you got those right, good job. Go ahead and try number 5. When you come back, we'll do it together. Okay, we're back. So those are the answers for number 5. If you got those right, good job. Go ahead and try number 6, and when you come back, we'll do it together. Okay, we're back. So those are the answers for number 6. If you got those right, good job. Okay, so that's just some basic review of the trigonometric functions, and we also need to use these theorems here, the 30, 60, 90 triangle theorem and the 45, 45, 90 degree triangle theorem. So you may want to get a picture of those theorems. And remember, this is called the first quadrant, second quadrant, third quadrant, fourth quadrant. You may recall that, and you can get a picture of that if you want to. Now remember, angles in standard position are angles where the vertex is on the origin of the xy coordinate system. So that's that orange point is the vertex. And the initial side of the angle, which is the green line, has to be on the positive part of the x-axis. So that's what it means to put an angle in standard position. So here are 6 examples of angles in standard position. The vertex, the orange vertex, is at the origin, and the green initial side of the angle is on the positive part of the x-axis. And the red arc is the angle measure. Here are examples of angles that are not in standard position. The initial side is on the positive part of the x-axis, but the vertex is not at the origin. It should be there. Here's an example where the vertex is at the origin, but the initial side is not on the positive part of the x-axis. So again, these are not in standard position. Here's an example where the vertex is the vertex of the angle is not at the origin, and the initial side is not on the positive part of the x-axis. So this is again an example of an angle that's not in standard position. And here are some other examples of angles that are not in standard position. Again, for an angle to be in standard position, the vertex has to be at the origin, and the green initial side has to be on the positive part of the x-axis. The purple arrow is called the terminal side of the angle. So you have the initial side where it starts, and then you move, and the terminal side is where you stop. That's why it's called the terminal side. Terminal means to stop. Okay, so remember, when we calculate the values of trigonometric functions, we move right triangles around the quadrants. And again, this is quadrant number 1, 2, 3, 4. And rotating with a positive angle measure means that we're going to rotate counterclockwise. So it's the opposite of what we would think, right? Now let's say we want to calculate sine 60 degrees. The way that we understand this is by drawing a triangle in standard position. A triangle in standard position is a triangle where the adjacent side of the the angle in question is on the positive x-axis, and the terminal side is the hypotenuse. And again, the vertex of the angle in question must be at the origin. Now, notice we have here a 30, 60, 90 degree triangle. So we're trying to find the sine of 60 degrees. And because these functions are defined for right triangles, we have a right angle there. And by the triangle sum theorem, this angle must be 30 degrees, because if this angle is 90 and this angle is 60, that means this angle must be 30, because all the angles in any triangle, their measures add up to 180 degrees. That's the triangle sum theorem. Now, again, I want to give you a chance to take a picture of these theorems. You're going to need these theorems. So notice we have a 30, 60, 90 degree triangle. So we have the corresponding relationships between the sides. That's the 30, 60, 90 degree triangle theorem. So sine is the opposite side of the angle in question divided by the hypotenuse. Doesn't matter how big the triangle is or how small it is. If it's a 30, 60, 90 degree triangle, the ratios are going to be the same. The b factor is going to cancel out. So sine 60 degrees is root 3 over 2. But let's try rotating 120 degrees. Notice we get the same exact answer. Why is that? Well, because if we rotate 120 degrees, we draw a triangle in the second quadrant. And remember, we always drop the vertical angle to the x-axis. We never drop it to the y-axis. And we call this green angle the reference angle, which is the exact same angle that we had when we were in the first quadrant. So we have the same exact triangle. It's a 30, 60, 90 degree triangle. Same relations, but there's just one difference. The adjacent side of the green angle is negative, because this side is to the left of the y-axis. So this green angle we call the reference angle, because even though our angle is 120 degrees, we can't really use that in a right triangle. Because if this angle is 90 degrees, this angle can't be 120, because that would not be possible. Remember, all the angle measures have to add up to 180 degrees. So if you add 120 with 90, you get 210 degrees. That doesn't leave any room for the third angle. Plus, this is way bigger than 180 degrees. So the reference angle is the acute angle between the x-axis and the terminal side. So it's this angle here. So the x-axis and the terminal side. Okay, so here's some other examples where we have the same reference angle. So sine 240 degrees and sine 300 degrees, they're the same as sine 60 and sine 120. You get the same answer, root 3 over 2. The only difference is now it's a negative. So why is that? Well, if you rotate 240 degrees, your reference angle is the same 60 degree angle. Again, it's the acute angle between the x-axis and the terminal side. But now, not only is your adjacent side negative because it's to the left of the y-axis, but your opposite side of the angle is negative also, because that side is below the x-axis. So now when you divide the opposite side of the green angle by the hypotenuse, you get a negative number. And over here we have the same thing. Same reference angle, but the opposite side is negative, because it's below the x-axis. The adjacent side is positive, but we don't really care about the adjacent side because we're calculating the value of sine. So that's how this works. This should be somewhat familiar to you because we've done many problems like this in my trigonometry course. If you're a little rusty on this, that's okay. We're going to review. So let's do some practice problems. It says draw each angle in standard position, write the measure of the reference angle, and draw a triangle to help find the value of the trigonometric expression. Then find the value of the trigonometric expression without a calculator. So we're not using a calculator. So let's draw the angle in standard position. That's the angle, 45 degrees. The standard position means the vertex is at the origin. Let me draw that again. So the vertex is at the origin, the initial side is on the x-axis. So we drew in standard position, and 45 degrees is the reference angle in the first quadrant. The first quadrant is the only quadrant where the actual angle is the same as the reference angle. And it says draw a triangle to help find the value of the trigonometric expression. So I'm going to draw the triangle. It's going to be a right triangle because these functions are only defined for right triangles. Then I'm going to find the value of the trigonometric expression without a calculator. So how can I do that? Well, because this is a 45-degree angle, this angle must be 45 also, because again, the angles all add up to 180 degrees. So I'm going to make this green because that's the reference angle. All reference angles are going to be green in this class. So now, because this is a 45, 45, 90 degree triangle, these sides are going to be the same, and the hypotenuse is going to be that value times root 2. That's the 45, 45, 90 degree triangle theorem. That's this theorem down here. So you should be somewhat familiar with that theorem. So sine 45 is going to be the side opposite the 45-degree angle divided by the hypotenuse. The b's cancel out, and we need to rationalize the denominator. So I'm going to multiply both sides by root 2, and I'm going to use a different color. Multiplying both sides by root 2, we have root 2 over root 4, which is root 2 over 2. Okay, so we drew the angle in standard position, formed a triangle, wrote the reference angle, and used the 45, 45, 90 degree triangle theorem. So now we have an angle that's 120 degrees. I'm going to write the angle in standard position. It's going to look something like that. Roughly something like that. So that's the angle in standard position. I'm going to draw a triangle. It's got to be a right triangle because these functions are only defined for right triangles. Now I'm going to find the reference angle. So you tell me, what is the reference angle? That's the angle between the x-axis and the terminal side of the angle. So what is this angle here? Well, we rotated 120 degrees. How much farther do you have to go to get to 180 degrees? Well, 60. So the reference angle is 60 degrees. Now, if this angle is 90 and this angle is 60, then what is the leftover angle? That's 30 degrees. Because again, all the angles must add up to 180 degrees. So we have a 30, 60, 90 degree triangle, which means that if this side is b, then this side is b root 3, and this side is 2b. How do we know that? Well, that's the 30, 60, 90 degree triangle theorem. Again, you should be somewhat familiar with this, and you need to take a picture of this so that you can have it in front of you, so you don't have to constantly refer back to my work. Now, there's one thing that I forgot. This side has to be negative because it's to the left of the y-axis. So now cosine 120 is going to be the side adjacent the green reference angle divided by the hypotenuse. So that's negative 1/2. So it's very important to understand that when you calculate these values, you use the reference angle. So cosine is the side adjacent the reference angle divided by the hypotenuse. It wouldn't make any sense to use 120 because you can't have a right triangle with a 120 degree angle. That doesn't work. Okay, so let's try some more of these. Tangent 225 degrees. So we're going to rotate 225 degrees. So that is the angle. And then we need to draw a triangle to help us find the values of these trigonometric functions. And these functions are only defined for right triangles, so we need a right angle there. Now help me find the reference angle. What would that reference angle be? So if you rotate 180 degrees, that's a half rotation by definition. And if you want to go to 225 past that, how many more degrees do you go past the x-axis to get to the terminal side? Well, you have to go 45 more degrees, because 180 plus 45 is 225. So we have the reference angle, we have a triangle, we have the angle in standard position, and if that angle is 45 degrees, then by the triangle sum theorem, this angle must be 45 degrees also. So this is a 45, 45, 90 degree triangle. So whatever this side is the same, and this side is that number times root 2. That's the 45, 45, 90 degree triangle theorem. But I made a mistake here. This side is to the left of the y-axis, so it has to be negative. And not only that, but this side is below the x-axis, so it has to be negative. I'm going to make that bigger. So now we're ready to calculate tangent 225 degrees, but we must use the reference angle. That's so important to understand. You must use the reference angle. The reason we call it the reference angle is because that's the angle we use when we calculate a tangent 225. When we're trying to figure out what is the opposite side and the adjacent side, we're talking about the reference angle. So the opposite side is negative b, and the adjacent side is negative b, so those cancel and we get 1. Okay, so let's try another one. Secant 330 degrees. We're going to rotate 270 and then 60 more. That'll give us about there. So we drew the angle in standard position. We formed a triangle. It's got to be a right triangle. And what is this angle here? Help me figure out what this angle is going to be. In order to get a complete rotation, you have to keep going 30 more degrees. So that reference angle is going to be 30 more degrees, or 30 degrees. Again, the reference angle is the acute angle between the x-axis and the terminal side. So if that angle is 30, then this angle must be 60 by the triangle sum theorem. And this side is going to be b, this side is b root 3, and this side is 2b by the 30, 60, 90 degree triangle theorem. But this side has to be negative because it's below the x-axis. So now we're ready to calculate we have to use the reference angle. So secant is the hypotenuse divided by the side adjacent to the 30-degree angle, which is b times root 3. And I forgot to mention the hypotenuse is always positive. So be aware that the hypotenuse is always positive. Now that's not going to be true in the next class when we're dealing with polar coordinates or polar equations. The hypotenuse is not always going to be positive, but when you're calculating the value of these trigonometric expressions, the hypotenuse is always considered to be positive. So we're going to have to rationalize that fraction. So multiply both sides by root 3, and we get 2 root 3 over root 9, and root 9, of course, is 3. So that is the answer. Okay, so I want you to take a picture of these problems, and they can help you with number 11. This is an angle in the first quadrant, so I want you to draw your angle, and this is going to be a 30, 60, 90 degree triangle. So I'm going to give you one last chance to take a picture of this information. So you should have that in front of you. And I want you to try number 11. When you come back, we'll do it together. Okay, we're back. So we're going to draw the angle in standard position and form a triangle. And this is the one case where the reference angle is the actual angle measure. When the angle terminates in the first quadrant. Okay, so if that angle is 60, this angle must be 30. And so this is a 30, 60, 90 degree triangle. So this side is B, this side is B root 3, and this side is 2B. So cotangent 60 is the side adjacent divided by the side opposite. The b's cancel out. And then we're going to multiply both sides by root 3. And we get root 3 over root 9, which is root 3 over 3. So if you got that right, excellent. So go ahead and try number 12. When you come back, we'll do it together. Okay, we're back. So we're going to draw the angle in standard position. The reference angle is going to be 45 degrees, which means that this angle has to be 45 degrees also. And because it's a 45, 45, 90 degree triangle, this side, if it's B, then this side is going to be B also, and this side is going to be B root 2. But remember, some of these sides are negative, so that's going to be a negative. So now we use the reference angle to calculate sine 135 degrees. So sine is the side opposite the reference angle divided by the hypotenuse. The b's cancel out. And then of course we have to rationalize the denominator. And then we get root 2 over root 4, which is root 2 over 2. So if you got that right, very good. Excellent. Okay, so try number 13. When you come back, we'll do it together. Alright, we're back, so I'm going to draw the angle in standard position and form a triangle, a right triangle. Then I'm going to find the reference angle, which is 30 degrees. Again, the reference angle is the acute angle between the x-axis and the terminal side. And if that angle's 30, then this angle must be 60, which means it's a 30, 60, 90 degree triangle. And so what that means is if this side is B, then this side must be B root 3, and this side must be 2B. That's what the 30, 60, 90 degree triangle theorem tells us. But remember, sometimes you have negative side lengths. This side is to the left of the y-axis, so it's negative. This side is below the x-axis, so it's negative. So cosecant, using the reference angle, is the hypotenuse divided by the side opposite the reference angle, so that is -2. So if you got that one right, excellent. Go ahead and try number 14. When you come back, we'll do it together. Okay, we're back. So we're going to draw the reference angle in standard position, then form a triangle. And we have to draw the reference angle, which is 45 degrees. Again, it's the acute angle between the x-axis and the terminal side of the angle. And so if that angle is 45, then by the triangle sum theorem, this angle must be 45 degrees. And if this side is B, then that means this side must be B. And this side is B root 2, because it's a 45, 45, 90 degree triangle. But this side has to be negative, because it's below the x-axis. So we're going to use the reference angle to calculate tangent 315 degrees. And so that's defined to be the side opposite the reference angle divided by the side adjacent, which is -1. So there you go. If you got that right, excellent. Okay, now remember, sometimes we have negative angles. If you have a negative angle measure, then you don't rotate counterclockwise, you rotate clockwise. So that brings us to about here. That's -135 degrees. The reference angle is 45 degrees, so it's a 45, 45, 90 degree triangle, which means this side is going to be -b, this side is -b, and this side is B root 2. So cosecant is the hypotenuse. Divided by the side opposite the 45 degree angle, which is -b. So that just simplifies to -√2. The b's cancel out. So again, if you have a negative angle measure, you rotate clockwise, not counterclockwise. So let's try another one of these. We're going to rotate clockwise because we have a negative angle measure. And so I can just write -30. I guess I'll write +30 so things don't get confusing. And this angle must be 60 by the 30, 60, 90 degree, well actually the triangle sum theorem, that is. And so the 30, 60, 90 degree triangle theorem tells us that if this side is B, then this side is B root 3, and this side is 2B. And of course this length has to be negative, don't forget that. So cotangent is the adjacent side of the reference angle divided by the opposite side of the reference angle, which simplifies to -√3. So those are some examples where we had negative angle measures and we were rotating clockwise. So try number 17. Remember to rotate clockwise, and when you come back, we'll do it together. Okay, we're back. So I'm going to rotate -225 degrees. which gets us about there. And the reference angle is 45 degrees, which means that this angle must be 45 degrees by the triangle sum theorem. So this side is going to be negative b, this side is positive b because it's above the x-axis. And so now we can use the green reference angle to help us. Secant is the opposite, or the hypotenuse, divided by the adjacent side. So that would simplify to negative root 2. So if you got that right, excellent. Go ahead and try number 18. When you come back, we'll do it together. All right, we're back. So we're going to rotate clockwise 300 degrees, and that's going to get us to about here. And the reference angle is going to be 60 degrees. By the triangle sum theorem, this angle must be 30. And if the side opposite 30 is b, then the side opposite 60 is b root 3, and the hypotenuse is 2b by the 30, 60, 90 degree triangle theorem. So cosine, according to the reference angle, is the side adjacent divided by the hypotenuse. So 1/2 is the answer for that one. So if you got that right, excellent. Okay, so those are problems where we didn't have to use a calculator. But just be aware that sometimes you have angles where we do have to use a calculator. So you want to get your calculator out, and remember, phones are not allowed in school. So you're going to have to use your graphing calculator. You should have a graphing calculator by now, and you're going to just press the mode button. If you're using a TI, press the mode button, and you want to use the arrow keys to make sure that you're in degree units. So it says radian and degree. Make sure degree is highlighted. If you're using a TI-84 Plus, push the blue second button and then mode button again, and that quits out of that screen. Then you're going to press the cos button, meaning cosine, and then enter 38, and then press the enter button, and then you have your value. So it's approximately 0.788 if we round to the nearest, if we round to 4 decimal places. And tells us here to draw the angle in standard position and a triangle, so 38 degrees will be somewhere around there. Doesn't have to be perfect. So 38 degrees is the reference angle. And cosine, let's see. So this is a positive value, because cosine is the adjacent divided by the hypotenuse, and these two sides are both positive. So now let's draw a tangent 120 or the 126 degree angle. That would be about there. Doesn't have to be a perfect angle. You don't have to get a protractor out. Now, what is the reference angle? The reference angle is 180 minus 126, so that would be 54 degrees. And let's calculate tangent 126. Push the tan button, then enter 126, and then press the enter button at the bottom right. And we get approximately negative 1.3764 if we round to 4 decimal places. These are the 4 decimal places here. So why is this negative? It's negative because the side opposite the reference angle is positive, but you're dividing by the side adjacent, which is negative. So a positive divided by a negative is a negative. So this side is negative because it's to the left of the y-axis. Okay, so I want you to try number 21. And when you come back, we'll do it together. All right, we're back. So sine 200 degrees, according to our calculator, is negative 0.342. And if we draw this angle, it's going to be somewhere around there. And the reference angle is 20 degrees. And the reason it's negative is because sine is the opposite side of the reference angle divided by the hypotenuse. And the hypotenuse is always positive, but this side is under the x-axis, so it's negative. So if you got that right, excellent. Go ahead and try number 22. When you come back, we'll do it together. Okay, we're back. So let's rotate 325 degrees. So that would get us to about there. And let's draw the reference angle. That's going to be 35 degrees. And let's use the calculator. Cosine 325 degrees is 0.8192. And by the way, these are part of the answers, so we should probably rectangle those. So the reason it's positive is because cosine is the adjacent side to the reference angle divided by the hypotenuse, and both of those values are positive. This length is positive because it's to the right of the y-axis. So if you got that right, excellent. So now we need to go to the situations where you have angles that are what we call quadrantal angles. 90, 180, 270, 360. Those angles are all multiples of 90. And in those situations, what happens is the triangles collapse. So for example, let's say your angle is approaching 90 degrees. So you got 45 degrees, then 70 degrees, then 87 degrees. Look what's happening to the triangle. It's collapsing. So when you get to 90, you have a collapsed triangle. But how do we define sine 90 degrees if there's no triangle? Well, it doesn't really have any meaning. Geometrically, it really doesn't have any meaning. But because the hypotenuse and the opposite side of the reference angle being 70 in this case, because the hypotenuse and the opposite side, which are used to define the sine function, because they're getting closer and closer to each other in length, again, compare these two sides. The hypotenuse is longer, but here this opposite side is getting closer and closer in length to the hypotenuse, and then when they get really, really close to when the triangle gets really, really close to the y-axis, that is the opposite side of the triangle, then those values are almost equal. And so mathematicians just define sine 90 to be 1, even though it doesn't really have any meaning geometrically, because the sine function approaches 1. Mathematicians just say that sine 90 is equal to 1, and the same logic applies in these examples. So we don't need to go over every example there, but you can look at that logic if you want. Sine is defined as the opposite side over the hypotenuse, but look what happens as the angle approaches 180 degrees. The opposite side is getting smaller and smaller to the point where it's going to get to 0. So mathematicians have defined sine 180 as 0 because as the angle approaches 180, the sine ratio approaches 0, so why not just make it 0? That's the logic that mathematicians use for that. But as you can see, using collapsed triangles to understand this is it's a little confusing, I guess. So we don't really use collapsed triangles to understand the values of these functions when we have quadrantal angles. Instead, we use these curves. If we graph the functions so that the x-axis represents the angle measures and the y-axis represents the resulting value of the trigonometric ratio, then we get these curves. And the green points of the curve are the special points where we have quadrantal angles. So we have 0 degrees, 90, 180, 270, 360. So the x value of the green points is the angle measure, and the y value is the actual value that we're looking for, the value of the sine function. So let's do some examples. Let's try sine 270 degrees. That's a collapsed triangle. So we count out 270 degrees on the x-axis, and then we ask, what is the y value of this point here? Well, it's -1. So the answer is -1. So this problem is asking if the angle is, or if the x value is 360, what is the y value of that point? Well, it's just 0. And if the x value is 0, what is the y value? 0. So this is all stuff that you've probably seen before. So -90 degrees, we're going to count out -90, and what's the y value of the corresponding point? That's -1. Again, we do this with quadrantal angles. But when you're calculating the value of sine 45 or 30 or 60, then this curve doesn't really do much to help us. We need the special triangles because we can't know what the values are just by looking at this curve. So sine -180, that is 0. That's 0 is the y value if the x value is -180. If the x value is 450, so go all the way out to here, what is the y value? Well, it's 1. So this is how we calculate the values of quadrantal angles, and I want you to try numbers 29 through 34. You're now going to use the cosine curve to help you. When you come back, we'll do it together. Okay, we're back. So cosine 90 is 0, because you're asking if the x value is 90, what is the y value? Well, it's 0. If the x value is 180, what is the y value? Well, that's -1. If the x value is 270, what is the y value? Well, that's 0. If the x value is 360, what is the y value? Well, that's 1. If the x value is 0, what is the y value? Well, that's 1. And if the x value is -90, what is the y value? Well, that's 0. So if you got those right, excellent. Okay, so now we're going to move to the secant function. So see if you can calculate values here. We have the secant graph, and we're going to use the same logic. So if the x value is 180, what is the y value? Well, that's just -1. That's right here. If the x value is 90, what is the y value? Well, that's actually a trick question. There's an asymptote at 90 degrees, so there is no graph at 90 degrees. The graph is the red part. And at 270, we have the same situation. It's a trick question. At -90, Another trick question. The value of secant is undefined because there's an asymptote. And at 0, the x value is 1. And at negative 180, the x value is negative 1. So I want you to try number 41 through 46. You now have to use the cosecant graph, and when you come back, we'll do it together. Okay, we're back. Cosecant 90 degrees is 1. Cosecant 180 is undefined. Cosecant 270 is negative 1. Cosecant 0 degrees is undefined. Cosecant negative 90 is negative 1. Cosecant 360 is undefined. So there you go. Alright. So now let's move on to the tangent function. We have the same logic with the tangent function. So if the x value is 180 degrees, what is the y value? That's 0. If the x value is 90 degrees, what is the y value? Well, there is no y value because there's no point. It's undefined. There's an asymptote there. If tangent is 0, what is the y value? It's 0. If tangent is negative 270, what is the y value? Well, there is no y value. There's an asymptote there. Negative 180, the y value is 0. And 360, the y value again is 0. So do you see how we use these graphs of the trigonometric functions to help us calculate the values of quadrantal angles? Try numbers 53 through 57, and when you come back, we'll do it together. Okay, we're back. So if the x value is 90, what is the y value? That's 0. If the x value is 180, what is the y value? There is no y value because there's no point. And this one would be 0, and this one would be undefined, and this one would be 0. So if you got that right, excellent. Okay, so now we need to talk about coterminal angles. So coterminal angles are two or more angles in standard position. They must be at standard position. Two or more angles in standard position whose terminal sides have the same location. So notice that these angles are in standard position because the vertices are at the origin and the green initial side is on the positive part of the x-axis. But notice that the terminal sides are all in the same position or the same location. So that means that they are coterminal, meaning they end at the same place. And if you want to find the measures of coterminal angles, you simply add or subtract 360 degrees. For example, if you want to start with 50 degrees and find a coterminal angle, you can just rotate all the way around 360 degrees till you get to 410. So if you want to find a coterminal angle, then you would, and you're going to start at 50 degrees, and you would just start at 50 and add 360 because that's a complete rotation, and you'll get right back to where you started. So 50 degrees plus 360 is 410. So these are coterminal angles. But you can also rotate in the other direction. You can rotate in the clockwise direction by subtracting 360. So if you subtract 360, you go in the opposite direction and you'll get to negative 310. So these are all coterminal angles because the purple terminal side is in the same position. So here's some other examples of coterminal angles and some other examples. Again, you just take whatever angle you start with and you add or subtract 360 degrees. And notice that all of the purple terminal sides are going up. That means they're coterminal. All these sides are going to the left. They're all coterminal. And of course, the first example we gave, the purple side is in the first quadrant, and they're all at the same angle, or the same direction. The purple line is pointing in the same direction. So let's try some practice problems. It says here, the measures of angles in standard position are written below. Find the measures of 3 coterminal angles in standard position. So if this angle is 200 degrees, to find the measure of an angle that is coterminal, we just add 360 degrees. And we get 560 degrees. So there you go. That's the measure of an angle in standard position that is coterminal if this angle is in standard position. So we can add 360 once, or we can add it twice and go around again. That just means you're starting at 200 and then moving around one complete rotation once and then one complete rotation again. And then you get to 920 degrees. But we can also subtract 360 degrees starting from 200. Then we get negative 160 degrees. That's another coterminal angle. So these are all coterminal angles, assuming that they are put in standard position. The vertex at the origin of the xy coordinate system and the initial side on the positive part of the x-axis. So now we have negative 1 degrees. Let's find some coterminal angles. So I'm going to add 360, and we get to 359 degrees. That's coterminal with negative 1 degrees. Now we can start at negative 1 degrees and add 360 and then add it again. And then we get 719 degrees. We can start at negative 1 degrees and then subtract 360. And then we get negative 361 degrees. These are all coterminal angles. So I want you to try number 60, and when you come back we'll do it together. Alright, we're back, so we're going to take our angle and add 360 degrees, and we get 440. Then I'm going to take our angle and I'm going to subtract 360. I guess I'll do it the same way I did it before. We can add 360 twice, and we get 800 degrees. Then we can subtract 360, and we get negative 280. But I want to show you some other possibilities. Because you may have chosen to do this other ways. So we could take 80 and subtract 360 degrees and then subtract 360 degrees again, and we would get negative 800. That's also another example. We could have added 360 3 times, or so on and so forth. So you only need 3 answers. So if you got any of these answers, good. Go ahead and try number 61. When you come back, we'll do it together. Okay, we're back. So we're going to start with 0 degrees and add 360 degrees, and we have our coterminal angle. Then we're going to start with 0 degrees and add 360 degrees twice, and we get another coterminal angle. And then we can start with 0 degrees and then subtract 360 degrees, and we get negative 360 degrees. That's another coterminal angle. But if you want to, you can actually subtract 360 degrees twice, and then we get negative 720 degrees. That's another coterminal angle. But again, you only need 3 answers, so you don't need that last one if you don't want. You can choose any of these, and there's an infinite number of coterminal angles that you can choose. But you only need to find 3 according to what the problem tells us. So coterminal angles are going to be very important for the next class and the class after. Okay, so now it says here, use a calculator to show that the following statements are true. Then draw a reference triangle in standard position to show why each statement is true. So this is the statement. They're telling us that sine 35 degrees is equal to sine 395 degrees, and those two are then equal to sine negative 325 degrees. So we can't do this without a calculator because these are not special angles. So let's use the calculator. Sine 35 degrees, according to my calculator, is 0.577. Actually, 0.5736. And now let's calculate sine 395. According to my calculator, we have the same number. And now let's calculate sine negative 325, and according to my calculator, again, we get the same number. So why is that? Well, let's draw the triangle. So we have a 35-degree angle. That's 35 degrees there. And 395, rotate around. And we have another 35-degree angle, a reference angle that is. Now let's rotate negative 325, so it's a negative angle, so we have to go clockwise. And looks like it's going to get us in the same position. So the reference angle again is 35. So because we're in the same quadrant, quadrant 1, and the reference angle is 35, that means that the values of any trigonometric function of these angles, they should all be equal because these are coterminal angles. So we just happen to be using sine in this example. Let's do another problem here. So let's use our calculators to find tangent negative 235 degrees. We get negative 1.4281, and tangent 125 degrees, we get the same thing, negative 1.4281, and tangent 485 degrees, we get the same thing, negative 1.4281. So why is that these numbers are all the same? Well, let's find this angle in standard position. That's going to be negative 235 degrees. And what is the reference angle? Looks like it's going to be 55 degrees. And now let's find 125 degree reference angle. That's going to be about there. And notice it's in the same, the triangle's in the same quadrant. And the reference angle is the same. And let's draw 485. So we're going to go all around 360. And 90 more would be 450. And then we're going to go 35 more, and we get about there. So again, we have the same location for the triangle, and the reference angle is 55 degrees again. So because the triangle is in the same quadrant and it has the same reference angle, the value of tangent is going to be the same in all of these examples. Now, why is it negative? It's negative because tangent of tangent of the reference angle is the side opposite, which is above the x-axis, divided by the adjacent side, which is to the left of the y-axis. So this side is negative and this side is positive. When you divide them, you get a negative number. So I want you to try 64. When you come back, we'll do it together. Okay, we're back. So cosine of 310 is 0.6428, and cosine of negative 50 is 0.6428, and cosine of negative 410 is 0.6428. So let's see why that is. 310 degrees would be somewhere around here. And the reference angle is 50 degrees. Cosine negative 50, obviously the reference angle is 50 degrees. And cosine negative 410, we're rotating clockwise, so 180, 270, 360, and then 50 more degrees. And we can see that the reference angle is the same again. So the reference angle is 50 degrees. So because the triangles are in the same quadrant and the reference angle is the same, that tells us why these ratios are all equal. So go ahead and try one more of these, 65. When you come back, we'll do it together. Okay, we're back. So sine 200 degrees is negative 0.342. Sine 560 degrees is the same thing. And sine negative 160 degrees is the same thing. So why is that? Well, let's rotate 200 degrees. The reference angle is 20, and our angle is in the third quadrant, or our triangle is in the third quadrant. Now let's rotate 560 degrees. So that's 360. And then 90 more would be 450. And if we go 90 more than that, now that would be 540, and then it's going to be 20 more to get to where we want. And the reference angle is again 20 degrees. So this is a 200 degree angle and a 560 degree angle, and let's try a negative 160 degree angle. That gets us to here, and again we have the same location for our triangle, and the reference angle is again 20 degrees. So because the triangles are in the same quadrant, quadrant 3, and they have the same reference angle, the value of these sine functions is going to be equal. Okay, now we're going to find all of the values of the trigonometric functions given 1. So here we're told that sine theta is 1 over root 17. And we're told that theta terminates in quadrant 2. And we're supposed to find the values of the 5 remaining trigonometric ratios. So if theta terminates in quadrant 2, it's going to be somewhere over here. Now we don't care exactly what the angle is, so it doesn't matter if your triangle is small or big or whatever. We don't really care. We're just trying to get a picture of what's going on. So that is theta. We don't know what theta is. But we do know that the side opposite the reference angle, which is the green angle, is going to be some number x, and the hypotenuse is going to be x times root 17. Now, why are we writing x? The reason we're writing x is because we don't know exactly what the side lengths are. We know the ratio is 1 over root 17, but that doesn't prove that one side is 1 and the other side is root 17 necessarily. Now, it turns out we don't really need to know the lengths of the actual sides because we're just looking for ratios. But I just want to write x just to let you know that we don't know exactly what the side lengths are. So let's let x equal 1 because it'll work for any value. So let's draw the triangle over here. And if x is equal to 1, then we have 1 and root 17. And the reason that we're letting x equal 1 is it just makes the math easier for us. So now we're going to use the Pythagorean theorem because this is a right triangle and we need to find the missing side, which I'm going to call b. So we have 1 squared plus the unknown side squared plus the hypotenuse squared. The hypotenuse is always c. And if we do the math, we end up with b squared is equal to 16. Therefore, b is equal to plus or minus 4. Okay, so we need to know if this side is going to be positive 4 or negative 4. And so if you look at the triangle, you can see what it's going to be. This side is to the left of the y-axis. So it's going to be negative 4. So we can rewrite the triangle. We have theta, and this side is root 17, this side is 1, and this side is negative 4. So this is the triangle that we're going to use with our green reference angle to calculate all the values of the remaining values. So we know that sine theta is 1 over root 17, but now we have to find all the other values. So that's how we do this. We just use this triangle that we came up with this information here. So cosecant theta is equal to the hypotenuse divided by the side opposite the green reference angle. So that would just be root 17. Secant theta is the hypotenuse divided by the side adjacent the green reference angle. Cotangent theta is the side adjacent the green reference angle divided by the side opposite. So that's negative 4. And cosine theta is the side adjacent the green reference angle divided by the hypotenuse. And of course we have to rationalize that. So we can multiply both sides by root 17. And we're out of room, but the final answer is going to be negative 4 root 17 over 17. Okay, and then tangent theta is the side opposite the green reference angle divided by the side adjacent. So 1/4. So that is how we do those types of problems. Okay, so let's try one more of these before you try one on your own. So we're told that cotangent beta is 4/3 and beta terminates in the third quadrant. So we don't care exactly what the angle is going to be. We don't need to know the exact angle. But we do know that it terminates in the third quadrant, so I'm going to draw an angle that terminates in the third quadrant. And this angle is beta, and the green reference angle is what we're going to use to calculate the values. These side lengths are going to both be negative side lengths, because this side is to the left of the y-axis, this side is below the x-axis. So cotangent beta is equal to negative 4x over negative 3x. And we're using x because we don't know exactly how big or small the triangle is. We don't really care. We're just looking for the ratio. But let's let x equal 1. It can be anything, and the ratios are going to be the same. Just for convenience, let's let x equal 1. And if x is 1, then this side will be negative 4, this side will be negative 3. And we're looking for c, so we're going to use the Pythagorean theorem. We need c so that we can calculate these other values here. So a we can make negative 4, and we need parentheses. B is negative 3, we need parentheses. Then we have 16 plus 9 is equal to c squared. 25 is equal to c squared, and c is equal to plus or minus 5. But remember, the hypotenuse is never negative. At least not when you're calculating basic trigonometric values. So the hypotenuse is 5. That angle is beta. And we're going to use the green reference angle to calculate our values. This side is negative 4, and this side is negative 3. So now we're ready to go. So cosine, using the information down here, cosine is the side adjacent the green reference angle divided by the hypotenuse. So negative 4/5. Sine beta is the side opposite divided by the hypotenuse, and so on and so forth. Cosecant is the hypotenuse divided by the side opposite. Secant is the hypotenuse divided by the side adjacent. And tangent beta is the side opposite the green reference angle divided by the side adjacent. So that simplifies to 3/4. Okay, so I want you to take a picture of all that information. Okay, so go ahead and try number 68. And when you come back, we'll do it together. Alright, we're back. We're going to draw the triangle in the first quadrant because they tell us it's in the first quadrant. And the adjacent side, we're going to make 8x and the hypotenuse 17x. We're writing an x because we don't know how big or small the triangle is. This is just a ratio. It doesn't tell you how long the sides are. But for convenience, we're going to write, we're going to let x equal 1. So if x is equal to 1, let's draw that triangle. This side is 17 and this side is 8. Now we're going to use the Pythagorean theorem. Hypotenuse is 17 and a would be 8 squared. So we have 64 plus b squared is equal to 289. And 289 minus 64 is 225. And so b is equal to plus or minus 15. You can use your calculator for that if you need to. So now we have to ask the simple question, is b positive or negative? Well, of course it's positive because it's above the x-axis. So we change it to a positive 15. And then we can draw our resulting triangle, and this is alpha. And remember, when you have a triangle in the first quadrant, the reference angle is the actual angle. So this side is 17, this side is 8, and this side is positive 15. So now we can calculate our trigonometric values. Sine is the opposite side of the green reference angle over the hypotenuse. Tangent is the opposite side of the green reference angle over the adjacent side. Cosecant is the hypotenuse over the opposite side. And secant is the hypotenuse over the adjacent side of the reference angle. And cotangent alpha is the adjacent side over the opposite side of the reference angle. So if you got that right, excellent. Go ahead and try number 69. When you come back, we'll do it together. Alright, we're back. So we're told that this angle terminates in the fourth quadrant. We don't know what the angle is. We just know that it terminates in the fourth quadrant. And if cosecant omega is equal to negative root 7, then we can write the ratio as negative x root 7 over x. Actually, the negative would be in the denominator because the hypotenuse cannot be negative. So that means we have x root 17 as the hypotenuse, and this side is negative x. So now for convenience, let's let x equal 1. Let's redraw the triangle. This side is going to be root 17, this side is negative 1, and we're looking for b. So let's use the Pythagorean theorem. A is negative 1, and yes, you do have to use parentheses. The hypotenuse is root 17. And if we do the math, we get the following equation. Subtract 1 from both sides, we get 16. And then b is equal to plus or minus 4. Now, is it going to be positive 4 or negative 4? Well, you tell me. Is this side positive or negative? Well, it's to the right of the y-axis, so it's going to be positive. So our triangle is down here, and the angle is here. That angle is omega, and our reference angle is going to be here. This side of the triangle is 4, and this side is root 17, and this side is negative 1. Okay, so now we're ready to calculate. So cosine omega, the green reference angle is our reference angle. The side adjacent the green reference angle is 4. The hypotenuse is root 17. Rationalize the denominator and you get the following. Sine is the side opposite the green reference angle over the hypotenuse. Rationalize the denominator and you get the following. Secant omega is the side, what's the hypotenuse, divided by the side adjacent omega. And tangent omega is the side opposite the green reference angle over the side adjacent the green reference angle. Cotangent omega is the side adjacent the green reference angle over the side opposite the green reference angle. So if you got those answers, Excellent. Okay, so let's try some other types of problems. So it says here the coordinates of points are given below. If each of these points lies on the terminal side of an angle in standard position, find the values of the 6 trigonometric functions of the angle. So we have a point here, and in order to demonstrate this, I'm going to plot the points. So 1, 2, 3, and then -1. So that point would be roughly there. Doesn't have to be perfect. And we're told that this point is on the terminal side of an angle in standard position. So if this is the initial side, that has to be the initial side because the angle's in standard position. We're going to rotate, and our terminal side of the angle is going to go through that point. And so we're asked to find the values of the trigonometric ratios here of that angle. And the angle doesn't really have a name, so we're just going to name it theta. And remember, the dark green is going to be the reference angle. Now this point here could be anywhere on this terminal side, and you get the same answers for your trigonometric functions. Because remember, it doesn't really matter how big or small the triangle is. These values are ratios. So as long as that point is on that purple terminal side, then the relationships between the sides of the angles are going to be the same. But to make things convenient, we're just going to pretend that that's the corner of the triangle there. And if that's the corner of the triangle, the vertex, the bottom vertex, then that means that this green length here is 3, and this length down here is -1. So we have the lengths of the legs of the triangle. And so now we can bring the triangle out. And of course it's a right triangle. And we need to find the hypotenuse of the triangle because we're going to need it to calculate some of these values. So let's use the Pythagorean theorem. So we have a squared plus b squared is equal to c squared, and that is 9 plus 1 is equal to c squared. So c is equal to plus or minus root 10, but remember, when you're calculating the values of these basic functions, the hypotenuse is always defined to be positive. So now I'm going to redraw this triangle, and the angle in question is that angle there, theta, and of course we're going to use the green reference angle, and the sides of the triangle are 3, -1, and root 10. So now we're ready to calculate the values of the trigonometric functions. So sine is the opposite side of the green reference angle divided by the hypotenuse. Multiply both sides by root 10 to rationalize the denominator, and we get the following. And cosine theta is the side adjacent the green reference angle divided by the hypotenuse. Multiply both sides by root 10 to rationalize the denominator. And tangent theta is the side opposite the green reference angle divided by the side adjacent. Cosecant theta is the hypotenuse divided by the side opposite the green reference angle. Secant theta is the hypotenuse divided by the side adjacent the green reference angle, and cotangent theta is the side adjacent the green reference angle divided by the side opposite. So we get -3. So that's how you do these particular types of problems. Now let's try one more of these problems. These values here are somewhat familiar. We'll count out 2√3, and 2 is going to be a little shorter than 2√3. So let's say that's 2√3. Let's go out a little farther. So that's 2√3, and then 2 might be like so. It doesn't have to be perfect. And so this is the angle theta, and the reference angle is going to be the same angle because we're in the first quadrant. And this point is 2√3, 2. And what that means is that the length of this side has to be 2√3, and the length of this side has to be 2, just based on the definition that we use for rectangular coordinates. So again, those values probably seem somewhat familiar. Let's look at our 30, 60, 90 degree triangle. Remember, that theorem tells us that if you have a 30, 60, 90 degree triangle and the side opposite 30 is b, then the side opposite 60 is b√3, and the hypotenuse is 2 times b. But look at these numbers here. Those legs correspond. Because we know we have a right triangle, and we know we have these relations, we can see that this is a 30, 60, 90 degree triangle. And b is equal to 2. So 2b is the hypotenuse, so the hypotenuse is 4. So now let's draw the triangle. And write the side lengths. So this side is 4, this side is 2, and this side is 2√3. And now we can calculate the values of our trigonometric ratios. So sine theta is going to be the side opposite the green reference angle over the hypotenuse. So that's 1/2. Cosine theta is the side adjacent the green reference angle divided by the hypotenuse, and that reduces to √3/2 if we divide both sides by 2. Tangent theta is the side opposite the green reference angle divided by the side adjacent. The 2's cancel out. Multiply both sides by √3 to rationalize the denominator. Cosecant theta is the hypotenuse divided by the side opposite the green reference angle, and secant theta is the hypotenuse divided by the side adjacent the green reference angle. Divide both sides by 2 to simplify, then multiply both sides by √3 to rationalize the denominator. Cotangent theta is the side adjacent the green reference angle divided by the opposite side, and they cancel out, and we have √3. So I want you to get a picture of these problems and use them to help you with number 72. Okay, so try number 72. When you come back, we'll do it together. Okay, we're back. So we're going to move out 2 units and then √5 units. So again, this is just kind of a reference triangle, so your triangle doesn't have to look perfect. I'm going to make that the point, and maybe we'll move this down a little bit. So the coordinates of that point are -2 root 5, and that point lies on the terminal side of an angle in standard position, and we'll call the measure of the angle theta. And the initial side is this side here. So we're going to make a triangle, and we know that this side of the triangle is -2 and this side is root 5. So the angle terminates in the second quadrant, and let's draw our triangle out here. So we're looking for the hypotenuse, and we need to use the Pythagorean theorem. So c is equal to ±3, but remember the hypotenuse is always defined to be positive when you're calculating the values of the basic trigonometric functions. So now let's draw the triangle again. So this is the angle theta, and of course we're going to use the green reference angle. And this side is root 5, this side is -2, and this side is 3. So we're ready to calculate our values of these 6 trigonometric ratios. So sine theta is the side opposite the green reference angle divided by the hypotenuse. Cosine theta is the side adjacent the green reference angle divided by the hypotenuse. And tangent theta is the side adjacent or side opposite the green reference angle divided by the side adjacent. Cosecant theta is the hypotenuse divided by the side opposite the green reference angle. Multiply both sides of the fraction by root 5 to rationalize the denominator. Secant theta is the hypotenuse divided by the side adjacent the green reference angle. And cotangent theta is the side adjacent the green reference angle divided by the side opposite the green reference angle. Multiply both sides by root 5, and we rationalize the denominator. So if you got those answers, excellent. So for number 73, you don't have to, but you can use a special triangle. I'm going to write the triangle theorem. So if this angle is 45, and this angle is 45, and this angle is 90, then that means that these two sides are going to be the same length, and the hypotenuse is going to be the length of that side times root 2. So you can use this to find the hypotenuse. You don't have to use it. You can still use the Pythagorean theorem if you want. But use this triangle if you want, or use the Pythagorean theorem. Try number 73. When you come back, we'll do it together. Okay, we're back. So this point is in the what terminates in the third quadrant. So the angle is going to be all the way down there into the third quadrant, and we have the terminal side of the angle goes through that point. And so we're going to make a triangle using that point as the corner, and of course this is the reference angle, and the legs of the triangle are negative 10 and negative 10. And so now you can see that we can use the 45, 90 degree triangle theorem to help us. B is just going to be negative 10. So we're looking for the hypotenuse, which is b root 2, so that would just be negative 10 root 2. Now remember that the hypotenuse is always defined to be positive. So we're not going to have a negative hypotenuse when calculating the values of the basic trigonometric functions. So I'm just going to say equal to positive 10 root 2. And let's draw our final triangle. So this is theta, and we have the green reference angle, and our side lengths are negative 10, and positive 10 root 2. I know that's kind of confusing, but remember the hypotenuse is never allowed to be negative when calculating these basic trigonometric functions. So we're ready to go. Sine theta is the side opposite the green reference angle divided by the hypotenuse. That reduces to negative 1 over root 2. Multiply both sides by root 2 to rationalize the denominator, and there you go. Cosine theta is the side adjacent the green reference angle divided by the hypotenuse. So you can see that's just going to lead to the same answer that we got for the first ratio. Tangent theta is the side opposite the green reference angle divided by the side adjacent the green reference angle, so that would just be 1. Cosecant theta is the hypotenuse divided by the side opposite the green reference angle, so we get negative root 2. Secant, we're going to get the same thing. And cotangent is the side adjacent the green reference angle divided by the side opposite the green reference angle, which again is 1. So if you got those answers, excellent. So that was the class today. If you'd like to take screenshots of the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and number 2 and number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. But don't go before you get your homework. Let's take a look at the homework. Here's screenshot number 1 of the homework, and number 2, and number 3, and 4, and 5, 6, 7, and 8. But don't go before you get the answers. Remember, it's not enough to attempt the homework. You must do it correctly and neatly and completely and keep it in order in your binder. So the answers to the homework are at the right, but those are only some of the answers. Here's screenshot number 2 of the answers. And screenshot number 3 of the answers. So be sure to get that homework done completely, correctly, neatly, and keep it in order in your binder. And I'll look forward to seeing you in the next class.